to sunlight.
Look at this thing.
The Hummer EV. Redneck Physics.
Yeah, because you're on cardboard, but you're going to be off cardboard in like half a second.
Uh-oh. Is it filming?
Yes.
Today we're gonna talk about something, and that something is when you heat an engine up, do you get more compression or less compression? We're gonna be looking at a 2-stroke chainsaw engine, and so we've got another jug here, and we've got a piston. These would go inside of here. This chainsaw still has its own jug and piston still in there. The things we want to know are the walls that enclose the combustion chamber gonna get wider apart or closer together when the engine warms up. And then also, even though these components have much less thermal mass than such a big hunk of metal like this, what are the rings gonna do when they heat up? Are they gonna get bigger? Are they gonna get smaller? Now, the piston itself, I'm not super worried about, because the thing that interfaces between the jug and the piston are these rings, and so that's really what's causing the air pressure to build up. If you didn't have any rings, you would just get 100% blow by, right? Because as the piston slid up and down in the chamber, all the air would just go around, just that the rings take up that gap. So, for very starters, let's look at what this is gonna do. Now this pipe right here, obviously is not exactly like this jug here, but you can see the similarities in as much as it's a connected ring of metal, right? It's not just a flat piece. So what are our guesses of what it's gonna do if we heat it up? Well, in some ways, we could think about, we know that when something gets hot, it expands. So maybe it'll expand in all directions. That means in to get tighter and out to get, well, just thicker. But also at the same time, if we think about taking a flat piece of metal and heating that piece of metal up, we know that if we measure it, that piece of metal is going to get longer because it's expanding, right? So if we visualize this not as a completed circle, but just as a really infinitely thin strip of metal wrapped around itself, well, in that case, it seems like it's gonna kind of push out. And if we consider it to be infinitely thin, then technically that would mean there'd be a bigger diameter inside. So which of those two things, which seem to both be valid arguments, are gonna be bigger? Which one's gonna overcome the other one? 0.815-ish. Okay, so with that in mind, let's cook this thing, heat it up a little bit. And now we're looking at about 0.83. So yeah, we grew by probably a little over 10,000ths of an inch there. That would mean that we should have lower compression when things heat up, right? Because these rings would have a bigger area to fill. But these rings are much, much less thermal mass. They're very, very small. They're gonna heat up a lot quicker. And so as they heat up, we know they're going to expand, right? Since we know that a flat piece of metal heated up gets longer, we know that these, since they're not constrained at all, right? They're broken in one piece in order for you to get them on, right? These can move around as much as they want. That's one reason why we're not gonna test them, is because it'd be really hard to get an accurate measurement of their diameter with calipers, since they're all squishy like this, regardless of their temperature. But we know these are gonna expand, and we know this is gonna get wider. So those two things contradict each other. I screwed in a little compression tester into the spark plug. Highly recommend you get this. If you want to buy a chainsaw at a garage sale, just hook one of these up to it. As long as it's above 90 PSI, buy the thing. If it's below 90 PSI, don't buy the thing. So, let's pull this over a few times and see what our cold compression is. Okay, so when we pull it cold, we're just a little shy, what is that, 140? All right, so now let's run this chainsaw. And just to let you know, I actually do not know what the result will be. We are at about 120. So it is actually substantially lower compression. So I guess what that tells us is that as things move along, even though these rings expand, these walls get bigger even faster than these. Now, obviously we only ran it for a few minutes, so maybe things would reach some other kind of equilibrium. But if you just run it for a few minutes, at least with a chainsaw, and probably with anything with similar ratios of materials, this actually expands faster than these expand. So surprisingly, at least I was surprised, as an engine warms up, it actually loses a little bit of compression. Now, please comment below if you feel like that is somehow fundamentally wrong. It surprised me as well, but that's just what we observed today. There could be all kinds of factors at play, but that's what we found. Thanks for watching RedNeck Physics.